Hi everyone, Krishna this side. In this video, I'll be covering this split array largest sum problem from the LeetCode. Problem number is 410, and this is basically similar problem as aggressive cows, but there is a slight modification in the statement. And there is another problem from the LeetCode, magnetic force between two balls. It is basically the same problem as aggressive cows from the Geeks4Geeks. You can try it out. There is no change in this problem, okay? But here it is slight changes in the problem statement. So let us go through the problem statement first, and then we'll write down the code as well. So given an integer array nums and integer k, split nums of that array into k non-empty subarrays such that the largest sum of any subarray is minimized. Okay, pretty much straightforward, right? Like stating, if we read this particular statement, it is kind of similar to aggressive cows, but the distance between the aggressive cows, whatever we are getting, out of which the minimum distance should be maximized. Sorry, it was maximum distance between two cows should be minimized. That was something like that heading in the aggressive cows, right? So here it is just reverse of that. Okay, we need to return maximize largest sum of the split array as a array is a continuous array of the part. Okay, that is pretty much clear for us. So let us take this particular example. We have k as 2, so two subarrays we can follow, right? So the first subarray is we can, if we try this as a subarray, one as a single subarray, then this entire array is going to be another one, because we can split it into two halves. Okay, so what is the sum that we get here? It is 5, 5 plus 4 9, 9 plus 4 14, right? So 14 is what we get. And here the, what is the smallest sum that we are getting? The largest sum that of any subarray is minimized. Okay, so what is the largest sum here? It is 14, right? Is it minimized? I mean, 14 is what largest sum we are getting. Okay, now we can try is like we can put a partition right over here. So 2 and 1 are a part of subarray, and 3 4 5 are part of another array. So the sum is like 3, and the other one is 7 plus 5 is 12. So this is giving 12. Okay, the next we can try is like we can put a partition right over here. So till here it is 6 as a sum we are getting, and next one is 9 that we are getting. So here it is basically 9 as the largest sum that we are getting. And next try out is like we can put right after the 4. So this is one partition of the array, and that is another one. Okay, so here it is like 10 we get, and from next it is 5. So what is the largest one? 10 is what we are getting. So out of all these possibilities, which is the minimum one, right? So largest sum that we are getting out of all the subarrays partitions whatever we tried, so which is the minimum one? 9 is the minimum, right? So that is the answer that we have to basically print. Okay, the idea is pretty much straightforward now. Since we have solved pretty much few of the problems of binary search, we get the idea that there should be a range in between which we have to get the answer, right? So here the range would be for minimum, what is the answer that we can consider? If the array has whatever the largest value that we get, that could be a minimum answer, right? But there is no point in looking that the array could be like it is going to have so many values, and if even if k's value is 1, still that is not the answer that we will going to get. So we can start either from 0 or the largest value that is available in the array. Okay, so let us start with the value that is having largest value in the subarray, because that could be the answer. Okay, ultimately. So anyway, this would just reduce the range. So we will start the loop pointing to the largest value that we have from the array. Okay, and high is basically the entire array sum. So if k value is basically 1. Okay, so we entire array whatever we have is we should have considered it as a sub array, and that is the sum that we have to give, and we cannot split it in halves, right? Because k is basically 1, so it should be a single entire array. So whatever the sum that we get, it is going to be the answer. So sum of entire array. Okay, sum of array. Okay, so that is going to be our high. So we got the range now. So based on this one, the range is like from 5. Okay, from 5 till 15 is what the range we have, because if we sum of all of these elements, we're going to get 15 as an answer. Okay, so it is like 5 6 7 till 14 15. Okay, that is the range that we have now. Okay, now we, our low is pointing to 5, the high is basically pointing to 15. We can get the median mean. So mid is basically, it is going to be, so it is pointing to 5, right? So mid is basically 10 in this case. So we try it with we start looking for 10. Okay, if 10 is possibly answer or not. So yes, we keep on going through this array. The moment we see that if whatever the minimum answer that we are considering, if any array sub array sum is passing beyond this 10. Okay, if it is greater than 10, we have to stop there, because we got a sub array whose previous whatever the array elements that we have collectively, if add all of them, we are getting some greater than 10, so we can stop there itself. So, okay, so let us take this same example here. If we add 1, is it greater than 10? No, right? So let us add 2 as well into that first sub array. When we add 2, is it going to be the answer is going to be 3? So is it greater than 10? No, right? So we add 3, the answer is 6. Let us add 4 as well, so the answer is 10. Okay, now 10 is basically satisfying here. Okay, till this all these sub arrays, the sum that we got is 10. Collectively the sum is 10 basically. So our sum is basically still lying under the constraint. Now we can add 5 as well. Now 15 is the answer that we are getting. Total sums answer. Okay. Whatever the current sum we are calculating, 15 is the answer that we got. So what we can do is we can increment the counter, whatever we are considering. So the currently counter is 0. So counter basically gets updated to 1. Okay, now 15 is the sum that we got. That means whatever the at correct index we are, so before that there should be a partition. So count is what we have added. So this whatever the sum that we got so far till that point, that is going to be into a sub array. Now next remaining 5 is in another sub array, we can consider that. And yes, now what we can do is basically we will again start looking, but at this after 5 we are actually breaking out of the loop. Okay, the moment we break out of the loop, that means we can partition this array in any ways, so that the mid whatever we are considering this 10 as the answer, it is basically going to satisfy, right? So we can now consider any sub arrays, even if the case value is basically 2 here. Still the array has been partitioned into two halves, but still if the k value is 3, even that is something what they have given, and we are trying for 10, and entire array we consider in one single sub array, that means we can split that array in any ways, right? So 10 is basically going to satisfy very easily. That is the case that I'm talking about. So currently count is 2 and k is basically 2 with our incrementation. Still it is satisfying. So yes, 10 is basically satisfying the answer. So here the change only is if at any point in time the answer is satisfying. If 10 is something what it is satisfying, right? So yes, if it is satisfying, whatever the values that are going beyond that 10, 11, 12, 13, 14 till 15, all those values definitely going to satisfy our need. Okay, and we need to get minimum answer, right? So we what we can do is currently answer will point to 10, and what we do is in this case high we will point to mid minus 1, because 10 is satisfying. Then we are not necessary to go beyond 10, right? Because all the rest values will definitely satisfy the condition. And low is basically pointing to the same at the start. It is basically 5. The high is now basically pointing to 9. Again we will try to get the mid of them. Again, we keep on checking the same things. The moment counter is greater than or equals to k, and still few elements are left into the array, that time only we will return false. Okay, there are only two conditions where we will return false. Those we will get it when I start writing the code, and I'll explain you again after writing the code as well, whatever the logic that I discussed. Okay, so let us define int low equals 0, int high equals 0, and run this loop for int I equals, let us get the value only, num from nums, and low equals math dot max between low and what is the this value num. Okay, and high basically going to be all the values from the array sum. Okay, the num is something what we will add. So we got this range. Let us define this while loop. Low less than or equals to high, and get the mid equals low plus high minus low divided by 2. Okay, we got the mid. Now we will basically check if, let us define a function. If possible, we pass this mid. Basically, if this is value that we are trying to check in the range, if this mid is satisfying or not, and pass nums k. If it is satisfying, that means basically rest all the values will satisfy, but we are looking for minimum value out of it. Okay, 10 is satisfying, 12, 14, we can see right over here, right? All these values basically satisfying, so our answer must be less than 10 or equals to 10. Okay, so yes, that is something what we are trying out. Now if it is possible, we just reduce high equals to mid minus 1 and store it into the answer, is whatever the mid that we have. Or else what we do is basically low we will point to mid plus 1. Okay, that is pretty much straightforward, right? If that is something what the value is not satisfying, then whatever the lower values that we have, those values will never going to satisfy at any point in time. Okay, so yes, you can try it out, whatever I'm trying to say with an example, and yes, we return the answer at the end. Let us write this is possible function, boolean is possible. We have this min distance int nums. Okay, and then we have this k as a counters, like how many times we can split them. And let us define a count which will basically designate to k, and current sum is basically at for this point 0 for int I equals 0, I less than nums dot length, I plus plus. If so, what we do is, see, at there is a point where in this array value is basically greater than mid as well, right? There could be a possibility. What we do is basically the first condition that we check is if whatever the nums of I, if it is greater than mid. If that is the case, that means we cannot split that array, right? Because whatever the mid that we are trying to consider, that value itself is less than the nums of particular index, right? So that value we cannot split, right? So we can return false from here. That is the first condition. Now we can add values into this one, nums of I, and we check that if current sum at any point in time, if greater than this min distance, that is the case, let us increment the counter current sum, let us point to this nums of I, so that in future the current sum will be having that index, and whatever the upcoming values that we are getting, we are keep on adding into the current sum. Okay, so if it was the 5 that was giving us out of bound, right, in this first example. So if we look here, when we're trying to calculate the sums, right? So here it was basically. So what was the mid for first? It was 10, right? Okay, for 10 till 4 the sum was 10. Okay, still it is not satisfying this condition. Whatever I have written right over here, current sum is basically 10. It is not greater than 10, right? Obviously it is basically equals. So what we have done is like we add 5 as well into the current sum. Now the current sum is 15. Obviously it is greater than 10. So if that is the case, the moment we see that the current sum is greater than 10, what we do is current sum, we will give this whatever the index value that we have, nums of I, we will point to that one. So current sum is been updated with current sum is basically 5, and the counter is something what we have incremented, and current sum is pointing to the nums of that value, so that even if we have 6 as an another value in this nums of array, what we can do is in the current sum 5 is what we have, because the split is something what we have keep before 5, that is something what we are denoting right over here. Okay, so current sum is basically pointing to that nums of I. So 6 is what, if we have another element, then current the 5 we will be adding 6. Okay, that is what we are trying to do, so I am pointing to that. Now we will check that if k equals count, basically this is the edge condition, means still the, if count is basically there, the current sum is having some value, right? Whatever the remaining values that we have, and still if there are any elements in the arrays, those will also get added into this one. And before that only the count is basically equals to k, that means there is some issue, we cannot form this one, the split of that current value with that current value. We return false at the end. If everything runs smooth, we'll return true. Okay, that is all about this one. So let us run this code. Let us see if there are any issues. Okay, there are multiple issues. Line number 8, it is not mid, it is min distance, and answer equals to mid. Okay, we haven't defined the answer, right? So let us define it. Int answer equals 0 basically. That is fine. Let's run this code. Okay, it is getting accepted. Let us submit this code as well now. So yes, it is pretty much same as aggressive cows problem, just a heading and statement is a bit different. And talking about the time complexity, it is going to be whatever the low and high, whatever the, let us suppose if the difference between them is m, whatever the range that we are getting, if it is m, so this binary search will going to take log m, and we are running this for loop each and every time, so it is going to be n log n if the length is something what we consider it as n. So yes, that is the time complexity for this one. We are not using extra space. So yes, we are done with that. Okay. So yes, still if you didn't get this particular solution, please watch the aggressive cows problem. There I have explained it properly. Okay. You guys will get the idea. Okay, with the time. But yes, it is pretty much a bit kind of hard level type of problem. But yes, with the time, you guys will get the ideas. Okay. Thank you for watching this video. Bye bye.